Good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. Today, we are going to see the design thinking approach on multiple integrals. In the previous classes, we have seen problems on multiple integrals, and now we are going to see the design thinking approach of it. We have our students to perform or represent the slides given here.
Design thinking approach to multiple integrals. Connecting mathematical concepts with real-world applications. A problem-solving perspective. Multiple integrals extend single variable integration to higher dimensions. Useful in physics, engineering, probability, and optimization. Design thinking makes learning or application more interactive, human-centered, and problem-driven.
So she have explained the design thinking concept using multiple integrals. What are we going to do in this particular slide? Now, we have the 5 steps of our design thinking strategy here. Now we have a student to explain it.
Design thinking strategy. Empathize. Understand students' struggles in visualizing and applying multiple integrals. Define. Frame the challenge. How can multiple integrals be used to solve real-time spatial and probability problems? Ideate. Brainstorm approaches. Geometrical visualization, real-world case studies, simulations. Prototype. Apply multiple integrals to practical problems, volume, mass, probability, density. Test. Validate with examples and reflect on accuracy and ease of understanding.
So here are the 5 steps of design thinking, and we have explained the strategies to be followed in this PowerPoint presentation.
Now we will empathize the given problem. Students often ask, how do we visualize the integration over 2D and 3D regions? Why are double or triple integrals important? Real-world things. Calculating material volume, heat distribution, probability over region.
So these are the real world needs. This is our empathizing here. What do we empathize? We have to calculate the material volume, heat distribution, and probability over regions. With this an empathizing statement as a problem statement, we will move on further.
Problem statement. Student find multiple integral abstract. We need to design learning or solution that make them practical, engaging, and directly linked to engineering challenges.
So we are in the motive of directly linkage to the engineering challenges. So that is what she have explained here as a problem statement.
Ideate. Use 3D models and graphs to represent integration regions. Connect with real-world examples, volume of a dam reservoir, triple integral, probability of random variable in a region, double integral, group activities, brainstorm applications in mechanical, civil, electrical engineering.
So these are the things to ideate. Ideation means formulation. Formulation of the design thinking process can be done here. Multiple integrals can be applied in all of these categories. And now we have the prototype of 2 such problems. One will be explained by the student.
Case example 1, engineering application. Find the volume of a solid bounded by surface using triple integral. Relating directly to the designing storage tanks or structures. Case 2, example 2, probability application. Evaluate probability of a particle in a region using double integral over probability density function.
So the first example will be considering as an engineering application. The second thing will be considered as a probability application. In the first thing, you will be finding the volume of a paraboloid, and the second thing, you will be finding the probability of a particle.
Outcomes. Deep understanding of multiple integrals through design thinking, better visualization and a real-world problem connections. Students become innovative problem solvers rather than rote learners.
Okay. Rather than roting something, which means mugging up something and explaining it out, we can make the students motivated themselves to learn the concepts very well and understand the concepts very well. This is what the outcome of our design thinking approach. So the 2 problems can be done using design thinking approach. One is the volume of a paraboloid can be found, and the second one is you can find the probability of a particle in a particular region. So in this prototyping, we have seen the first example as an engineering application, wherein the volume of a solid bounded by surfaces using the triple integral have been found. In previous classes, we have seen the triple integral problems which we can apply as a direct problem with the definite integral, which means with the limits. We have with the limits we have completed the problem and found out a particular answer for the given problem. But here we are going to directly implement this triple integral to the volume of a solid. We are just going to find the volume of a solid using the triple integral. So triple integral is related to volume. We can make a note that here this triple integral can be implemented in finding out the volume of a solid. Secondly, it is applied to the probability application, wherein the probability of a particle in a region using double integral over the probability density function have been analyzed. What do you mean by the probability density function, which we have learned in the previous classes? Probability density function is a function explaining the particular particular property of the particle or the function. So with that probability density function over the probability density function, we can find the probability of a particle. A particle is a moving thing happening in the particular region. So that particular probability of a particle can be found using this double integral. So directly this double integral is implemented to the probability of a particle. So this is what the two prototypes which are about to test in the design thinking process. Now we have a student to conclude the design thinking approach of our multiple integrals.
Conclusion. Design thinking brings clarity, creativity and collaboration in learning mathematics. Multiple integrals move beyond equations into practical solutions. Encourages students to think like engineers while learning maths.
So these are our conclusion using our design thinking concept. What we have done our equations into practical solutions, and later we have encouraged the engineers to learn while learning math itself. This is what we have approached using design thinking concept. Thank you.